This is a repeat one, logarithmic function, how to go from exponential to logarithmic or logarithmic to exponential. Remember, this is your base, and this is your exponent. And so the base goes under the exponent, so x equals a to the y. Base, exponent, so 3 to the negative third equals x. Please don't leave it like this. They're not asking you to change it. They're actually asking you to solve it. So 3 cubed is 27, so we get 27, still negative 1 exponent. And then negative 1 tells me the 27 goes in the denominator. So we have 1 over 27 equals x. Okay, same thing here. This is a base 10. If they don't tell you, it's a base 10. 10 and the whole logarithm equals the exponent. Squared equals x. So x equals 100. Now this is where we do have to talk domain. Whenever the variable is here, as in here, it cannot be a negative value. It has to be greater than 0. Whatever's in there has to be greater than 0. So we're good here. We're good here. Okay. So on this one here, again, x cannot be less than 0. So we have e to the negative third equals x. And that negative 3 tells me the e goes in the denominator, so this is 1 over e cubed, and we will leave it like that, equals x. Again, greater than 0. But now we have something like this. Now we need to talk about this one. So this is something to add to the domain flow chart, that 5 plus 2x must be greater than 0. So 2x must be greater than negative 5. So x must be greater than negative 5 over 2. Negative 5 over 2 is going to give us exactly 0. Anything larger than this will give us something greater than 0. So base to exponent equals 5 plus 2x. 2 to the 4th power is the same as 4 squared, 16, equals 5 plus 2x. Subtract 5, subtract 5. We get 11 equals 2x. Divide by 2, divide by 2. So x equals 11 over 2. And since that is greater than a negative number, we know it's going to be a good answer. Now, if you want to double check and make sure it's correct, you go back here and you plug it in. Okay, next one. Here we have it again. You have x plus 1 must be greater than 0, but also x minus 1 must be greater than 0. So this gives me x is greater than negative 1. This gives me x is greater than 1. We have to go with the smaller of the two. Anyways, if I did an overlap, here's 0, here's negative 1, and it's any value this way, and then there's positive 1, and it's any value this way, not included, so we have to go with the 1. So any answer we get must be greater than 1. Okay, so I get to remind you that this negative means divide. So I log base 2 of x plus 1 over x minus 1 equals 2. You cannot do anything here until you're down to 1 log. So you have to be able to put these together. My base, my exponent. So I have 2 squared equals x plus 1 over x minus 1. So x plus 1 over x minus 1 equals 2 squared, or 4, over 1. I'm going to cross multiply. So I get 4 times x minus 1 equals x plus 1. Distribute 4x minus 4 equals x plus 1. I'm going to move the x's this side, my whole number to that side. So I get negative x plus 4 plus 4, and I get 3x equals 5, so x equals 5 over 3. And I just needed a number greater than 1. Barely, but 5 over 3 is greater than 1. So a lot of algebra, once you get out of logarithms, this is just a lot of algebra that you should already know how to do. By the way, well, again, logarithms cannot be 0. What's inside the log cannot be 0. So you never have to worry about getting a 0 in the denominator. You've already taken care of it with the domain. Okay, next one. There's that negative again. So I have log x plus 5 over x minus 3 equals log of 2. Now, this is a property we learned in the last video, is that you have a log with the same base equal log of the same base. You can just simply cancel them out. So I'm left with x plus 5 over x minus 3 equaling 2 over 1. Cross multiply. So I get 2 times x minus 3 equals x plus 5. Now I should put out a reminder that when you cross multiply, the purpose of that is to get rid of your fraction. I'm really just getting a common denominator and then being able to throw out my denominator. I forgot to do the domain, so let's pause for a second and do domain. So if I have x plus 5, he's got to be greater than 0, so x would have to be greater than negative 5. But I also have x minus 3 has to be greater than 0, so x would have to be greater than 3. And you always go for the larger of the two values, unless this was pointing the other direction. Then you go to the smaller of the two values. So I need all my values. Any value I get must be greater than 3. Okay, distribute the 2. So back to the problem. Distribute the 2. 2x minus 6 equals x plus 5. Subtract x. Subtract x. Add 6. Add 6. So I get x. These cancel out. These cancel out. Equals 11. Definitely larger than 3, so it's a good value for me. Okay, one I have x is going to be greater than 0, and then I have the other x minus 4 has to be greater than 0, so x would have to be greater than 4. There's my domain. The minus sign means divide, so I have the natural log of x over x minus 4 equals the natural log of 3. Again, I have the same thing on both sides, so they can cancel out, kind of like squares canceling out, radicals canceling out. So I have x over x minus 4 equals 3 over 1. Again, cross multiply, get rid of the fraction. So I have 3 times x minus 4 equals x. Distribute. 3x minus 12 equals x. Because I only have x here, I'll move the 3 over. Subtract 3x, subtract 3x. I get negative 12 equals negative 2x. Divide by negative 2, divide by negative 2, and we get x equals 6. And since it's greater than 4, it is a good answer. Now, if you're still stuck on the domain, it's just that it has to be the larger of the two domains. Sorry, not the larger, the smaller. This includes 0 through 3. This one does not, so I grab this one. Okay, next one. So we have, let's check our domain. X plus 4 must be greater than 0, so x must be greater than negative 4. x minus 4 is greater than 0, so x must be greater than positive 4. There's my domain. Plus means multiply, so I have log base 5 of x plus 4, x minus 4, equaling 2. I'm going to go ahead and multiply those two together. Log base 5 of x squared minus 16, for those who have to see that, x plus 4, x minus 4. Follow this out, you get x squared minus 4x plus 4x minus 16, and these two cancel out, so you're left with x squared minus 16 equals 2. And then we have to go back to the base exponent, base exponent, base exponent. So I have 5 squared equals x squared minus 16. So I have 25 equals x squared minus 16. Add 16, add 16, and I get x squared equals the square root of 41. Square root both sides. I get x equals plus or minus square root of 41. But remember, x has to be a positive 4 or larger, so that throws out the negative. X is equal to the square root of 41. And to verify that this is greater than 4, your nearest perfect square here is 36, which is 6. So this is greater than 6, so we're good. Okay. And you can throw in the calculator and verify as well. But keep in mind that 4 squared is 16. This guy's bigger than 16, so we know we're good. Okay, another one. Got to clean up our both sides again. I have a plus here, so I have to multiply. I have a plus here, so I'll have to multiply. So I have log base 3 of x times x plus 1 equals log base 3 of 2 times x plus 3. Logs are exactly the same, so I can at this point go ahead and cancel them out. Do that, but I also need to distribute. So I have x squared plus x equals 2x plus 6. Move everything to this side because it's a quadratic, so I have to have it equal to 0. Minus 2x minus 6 minus 2x minus 6. So I have x squared minus x minus 6 equals 0. Now we didn't talk domain, so let's talk domain. X has to be greater than 0. X plus 1 must be greater than 0, so that gives us x must be greater than negative 1. So this one still wins. And then x plus 3 has to be greater than 0, so x must be greater than negative 3. And that is the largest of the 3 numbers, so that is the domain I want. Factor this out for those of you who need to see. Negative 6, negative 1 is going to be a negative 3 and 2. So this gives me factors of x minus 3 and x plus 2. And if we do the wagon wheel part, divide by the leading coefficient with a change sign, negative negative gives me x equals 3 and x equals negative 2. But my value has to be positive, so this is not a good value, but this one is. So only x equals 3 will work in this case, because if I don't want you guys going, well, if I put negative 2 in, well, negative 2, this is the only one that's going to be positive. This will give me a negative number. Even the calculator will give you an error. And this one's same. Even the calculator will give you an error. There are a lot of these. Okay, x plus 7, this is what I was referring to, that the 7 is not in parentheses, so we assume it is not part of the log. So I'm going to move the logs over and the whole number back over. So subtract 7, add log base 5 of x, add log base 5 of x. Okay, so I'm going to get 2 log base 5 of x, because these cancel out, it's going to equal to -3. By the way, there's only x's with the log, so x has to be greater than 0. And this is my base. Oh, we're not ready for the base yet. I got to bring the 2 up. So this is log base 5 of x squared must equal -3. Now we have our base, we have our exponent. So I have 5 to the -3 power must equal x squared. X squared equals 5 to the -3. This means x squared equals 125 to the -1. So x squared equals 1 over 125. And if I square root both sides, I get x equals plus or minus the square root of 1 over 125. Now, domain tells me it has to be a positive number, so we lose the negative. So x equals 1 over square root of 125. I will be okay with this answer, but for those of you who want to be able to clean it up, square root of 125 is equal to the square root of 25 times the square root of 5, which gives you 5 square root of 5. So this would be 1 over 5 square root of 5. And then if you multiply top and bottom by square root of 5, you'll get the square root of 5 over 25. Because 5 times 5, square root of 5 times square root of 5 is 5, and 5 times this 5 gives you 25. I'm okay with this answer. I'm not testing to see if you can take radicals out of the denominator. Okay, that got us to the end of that one. That was a very long video, just like the last one. Okay, so there's the rest of the homework. So I originally gave you 1 through 25, every other odd, and the rest is 29 through 51 odd. All right, there you guys go, and good luck.